Ashford.com.
Hello and welcome to Ashford.com. You are watching an interesting video on antibiotics are a bedrock of modern medicine.
Please read the disclaimer carefully.
The romanticized notion that life 100 or 200 years ago was natural and healthy is a crock. Life before antibiotics was not an easy life. Infant mortality rates were astronomical, people did not live nearly as long nor as well, and a simple scratch could maim or kill you, if the medicine of the times did not do it first. Even the food in the 18th and 19th centuries was adulterated and contaminated with microbes and chemicals. The discovery of antibiotics was a huge leap forward in modern medicine. For nearly 70 years antibiotics have been critical in the fight against infectious disease caused by bacteria and other microbes. Before then, one could lose limbs, become disabled or even die from an infection. Bacteria, however, have proven themselves much more creative and adaptive than we could have ever imagined, developing resistance to antibiotics at an ever-increasing rate. Skin and wound infections, gonorrhea, tuberculosis, pneumonia, septicemia, strep throat and childhood ear infections are just a few of the diseases that are now difficult to treat with antibiotics. 70% of bacteria that cause infections in hospitals are resistant to at least one of the drugs, or antibiotics, most commonly used to treat it. Antibiotics are a bedrock of modern medicine. Without them we risk returning to the days of Dark Age medicine, a post-antibiotic era. Dr. Margaret Chan, Director of World Health Organization, WHO, says that a post-antibiotic era means, in effect, an end to modern medicine as we know it. Things as common as strep throat or a child's scratched knee could once again kill. 1. Bacteria are likely the oldest life form on Earth. They've been around for anywhere from 3 billion years to 7 billion years. They are single-celled organisms, with no nucleus and no other membrane-bound organelles. They are literally the simplest living organism. Yet they continue to match our efforts to eradicate them or control them. Should be no surprise that they have learned a few tricks to surviving over the billions of years they've been here. This problem of antibiotic resistance was recently highlighted in a recent WHO, World Health Organization, report with detailed antimicrobial resistance levels worldwide. They called for a concerted effort to tackle the issue, which is now called a global health security risk. Resistance to medicines was once only seen in poorer countries due to a number of factors, but today antibiotic-resistant bacteria are in every corner of the globe, even in notoriously strict New Zealand where you need an X-ray to get into the country. With growing frequency we hear more and more about something called a superbug. Sometimes it is overseas in a country you have only seen in a National Geographic magazine, other times it is knocking at your front door. Mainstream media headlines include words like lethal, fatal, infectious disease nightmare and deadly. Documentaries talk of how dangerous they are, what we are doing, and discuss why we are still losing this battle with the small, invisible to the naked eye microbe. While we do not create the laws of nature, we do not always like them, think they are fair or even want to follow them, but to better control infectious disease, we have to at least understand the rules of the game. I am not a fan of scare techniques, or flashy misleading headlines. They do not work to solve a problem, they only add to it. Education, though more expensive and time-consuming than a scare technique, yields longer-lasting results. What makes a microbe a superbug, and just how super are we talking? Why not just make stronger medicine? Why the sudden increase in these antibiotic-resistant bacteria? Where are they coming from? How do I avoid and prevent them? What are we doing about them, and how are societies in general kept safe? There was a time in human history when traveling the lands required months. Life expectancy, for both sexes, averaged out to the late 30s and early 40s, where infections were once the #1 cause of death and populations were smaller and in isolated communities. When aggressive disease, or microbes, did rear its ugly head, it really had nowhere to go after infecting the small, mostly isolated community it was in. End of the line for the microbe. No fresh bodies to infect, it can't spread or live on. Today's growing world populations are not only immense in size but tightly connected around the globe. Traveling around the globe takes hours, not weeks and months. There is a growing elderly population, one consisting of immune-weakened people. This is a perfect mix for a health disaster. The only thing to make it more perfect would be microbes in which our antibiotics do not work against. Oh wait. I'm jumping ahead. As we learn to travel faster, airplanes, live longer, antibiotics, and live larger, cities. We were also upsetting the evolutionary balance of a microbe's ability to infect something, or its virulence. By trying to destroy the microbe, it learned to defend itself and how to attack, survive better. Despite the simplicity behind a bacteria, they have been around for a very long time, for a reason. Too many people today do not remember nor know of a life before penicillin or antibiotics. Before this wonder drug, life expectancy averaged out at late 30s to early 40s, and infections from small to grave killed many people. Penicillin was the first antibiotic and it saved thousands of lives when it was used in World War II. Discovered by Alexander Fleming in 1929, it was not mass-produced till the early 1940s, and was in development stages before then. Once it was mass-produced, it became the wonder drug prescribed for everything, from sniffles to sore muscles. Over the years it found itself into animal feed in low doses regularly given to them. Penicillin works by inhibiting the growth of bacteria, thus killing it. If you did not kill all of it, by not taking it for the full length of time prescribed, the surviving bacteria were resistant to penicillin. The same is seen when the bacteria were exposed to lower doses of it. Alexander Fleming discovered early on that the bacteria the antibiotics were inhibiting showed resistance under those same conditions, yet still it was never taken into consideration when antibiotics were becoming more misused and abused. There are only a limited number of antibiotics, and each time they're exposed to a different antibiotic they become resistant. Penicillin-resistant Staphylococcus appeared in 1940, despite having not been on the market for public consumption. Tetracycline made its way to the physician's war chest in 1950, Shigella bacteria resistant to tetracycline emerged 9 years later. Erythromycin hit the markets in 1953, and by 1968 the resistance was seen in strep too. It only got worse as antibiotics became affordable and their use increased greatly. Methicillin came out in 1960, resistance by 1962. Levofloxacin came next in 1996, and the resistant bugs were out that same year. The story is the same for nearly every existing antibiotic. Today we have multi-resistant bacteria, superbugs, or just antibiotic-resistant bacteria. This means, the antibiotics does not work. Bacteria are very simple in structure, despite their complex ways, resistance for one. Different families or classes of antibiotics have different methods, modes of action, of interrupting or killing bacteria, owing to the nature of their structure and whether they attack or inhibit cell walls, ribosomes or DNA. Beta-lactam antibiotics, including penicillin and cephalosporin, inhibit and or kill bacteria that have a cell wall, which are critical for the life and survival of bacterial species. They build their cell walls by linking molecules together. Beta-lactams blocks this process. Without the support of cell wall, pressure builds up inside the cell and eventually the membrane bursts. Humans and animals do not have cell walls, we have cell membranes. Some beta-lactams can attack cell membrane, instead of wall, and that could be toxic to our bodies and not just the bacteria. As such, these types of antibiotics are used only in clinical setting with supervision, such as colistin. Antibodies in the macrolide groups affect ribosomes, the cell's protein-building machines. Our cells have ribosomes as well, but there are differences that allow the antibiotics to select bacterial cells and not human cells, thus safe to take. By preventing ribosomes from building proteins, since proteins do all the cell's work, a bacterium that cannot produce protein cannot survive. Those in the quinolones group, such as ciprofloxacin and levofloxacin, treat infections like bronchitis and pneumonia. Quinolones cause the bacteria DNA strands to break when they begin to copy their DNA for dividing, and to be thorough in their jobs, they also prevent the breaks from being repaired. Without intact DNA, even bacteria cannot live or reproduce. There are a few other antibiotics that act on selected cellular and metabolic processes that are essential for the bacteria's survival, such as sulfonamides. Sulfonamides disrupt the bacteriophilic pathways, which are vital to division. Most antibiotics work against more than one microbe. The antibiotics that affect only a small range, or types, or bacteria are called narrow spectrum. Some antibiotics are broad spectrum and they work against many different types of bacteria, including those bacteria that are resistant to narrow spectrum antibiotics. The widespread, indiscriminate and improper use of antibiotics around the world promotes development of antibiotic resistance. Resistance is a process that microbiologists are still learning about, but they are sure of a few things. Such as, when we overuse antibiotics or use them when we don't need them, viral illnesses for example, resistance can develop. If we do not take the correct dosage or take as directed, resistance and bacteria can form. Stopping your pills too early, like most do when they start to feel better, could also cause resistance. Bacteria are single-celled microbes or organisms whose cell structure is simpler than other organisms in that there is no nucleus or membrane-bound organelles. Instead, their control center containing their DNA or genetic material is known as a plasmid. It is often in the plasmids that the genes for resistance to antibiotics are found. Being a living organism, their primary function is to reproduce and thrive. To thrive, they need to spread quickly and efficiently. Living things evolve over time, adapt to new surroundings and change in many ways to make sure their survival, or offspring's survival. So, if something like an antibiotic comes along and inhibits their growth, genetic changes can occur to help the microbe, or its offspring to survive the present attack or a future one. It's only logical that bacteria would have the ability to defend itself naturally, and this defense happens through selective pressure or genetic mutation. It can also happen by gene transfer, in different ways, some we are just starting to learn about. Selective pressure occurs when an antibiotic, or antimicrobial, agent kills off bacteria not resistant to it. Those that are resistant continue to live and thrive. The antibiotic given will kill the good bacteria as well as the bad bacteria. When the good bacteria dies off, the resistant bacteria become the dominant type in the microbial populations. Mutation occurs during reproduction, or dividing. Most bacteria reproduce by dividing every few hours, allowing them to evolve and adapt quickly to new environment conditions. During this replication, genes are sometimes not paired correctly and create a mutation. These mutations can result in resistance before ever being exposed to the antibiotic. Gene transfer can happen in a number of different ways, too many to list for this article, but bacteria species, similar or not, can share information, genes, often through the plasmids, but can also be shared via ribosomes. This information can then be shared with other microbes or passed along to offspring. The importance of gene transfer is that microbes can develop resistance without ever being exposed to the antibiotic. It needs only meet a bacteria that has been exposed. Bacteria can resist antibiotics in a number of ways, by developing the ability to neutralize the antibiotic before it can harm the bacteria, change the antibiotic attack site so that the antibiotic can't attach to the bacteria, and pump the antimicrobial out of their system before it does damage or prevent it from getting into the cell, or wall. Some bacteria can only become resistant to one type of antibiotic, but many more are resistant to many types of antibiotics, even ones they were not exposed to. Once antibiotics, of any class, no longer work on the microbe, it is technically incurable and can't be treated. In New Zealand, one of the strictest countries in regards to entry and clearing visitors for diseases, found itself fighting a superbug known as Penicillin-resistant. A pan-resistant organism, it repels every known kind of antibiotic. In 2013, the man infected died. There was nothing modern medicine could do for him. 3. bacteria that have no known antibiotics, are untreatable or are starting to become difficult to treat are known as nightmare bacteria. Mid-2013, the Centers for Disease Control warned that we're facing an onslaught of nightmare bacteria, a group of highly resistant, highly deadly microbes. 4. Even more concerning is the news of a cave in New Mexico, that has not had any human contact in a time range of 4 to 7 million years, is full of microbes that are resistant to multiple classes of antibiotics, including new synthetic drugs. 5. Glaringly exposing just how little we know and understand of microbial processes such as resistance. When we lose our ability to fight off infectious disease with antibiotics due to growing drug resistance, we lose a lot more than just not being able to treat infectious disease. There would be no surgeries of any kind, heart, lungs, brain, abdomen, none on internal organs such as bladders, guts or genitals due to those areas being high in microbes, good and bad. We lose our ability to treat cancer, transplant organs, do any medical procedure that relies on a permanent port into the bloodstream, such as kidney dialysis. There would be no way to implant devices for hips, knees, elbows or heart valves. Cosmetic surgeries are gone as well, liposuction, plastic surgery and even tattoos. We would not be able to treat people after traumatic events such as vehicle accidents or industrial mishaps. The safety of modern childbirth will be lost as well. No doubt infant mortality rates would skyrocket and deaths by labor would increase as well. Kids would be harder to treat for small things like falling out of a tree, scraping a knee or breaking a leg. The food industry would stumble for a few years at least and possibly longer. According to the CDC, 80% of all antibiotics go to agricultural animals or their feed. Our cheap food would become scarce and expensive as stock died off from once non-lethal diseases. Eggs, dairy and some vegetables and fruit would also be affected. CRE stands for the mouthful, Clostridium-resistant Enterococci. It's listed by the CDC as urgent, the strongest level. CRE is a highly contagious and multi-resistant bacteria that does not respond to the majority of antibiotics in use today. The WHO calls it one of the 3 greatest threats to human health. 6. CRE pathogens can cause infections in lungs, blood, urinary tract, and other parts of the body. In at least 48% of cases, patients die from the resulting infections. Some cases are being reported as untreatable. CDI is known as Clostridium difficile infection. Clostridium difficile, C. Difficile, bacteria are a common bacterium in the environment and in our bodies. But too much of one thing is a bad idea, and CDI happens, most often, when someone is on antibiotics for a long period of time in the C. Difficile bacteria have taken over the microbiome that is your bowels. When good bacteria are killed off from antibiotic use, C. difficile can grow and release toxins that can damage the bowel and cause diarrhea. According to the numbers, CDI kills at least 14,000 people out of the 200,000 it infects in the USA. 7. Gonorrhoeae is a sexually transmitted disease. It's being reported more often that medical community are finding untreatable cases. Right now one antibiotic still works, but there is not much agreement on how much longer. Ceftriaxone is the last defense, and recently in Japan it was shown to have high resistance to ceftriaxone. The CDC lists gonorrhoeae as urgent. It has been reported in 10 countries. MRSA is shorthand for Methicillin-resistant Staphylococcus aureus. This is more often than not a hospital-acquired infection, or other healthcare long-term setting. Though cases are rising of community-acquired infections, which is worrisome to many healthcare professionals. It can be beat with any antibiotic other than methicillin, and success rates are higher if you catch it early. To catch MRSA you have to touch someone infected or something they touched. It is listed as serious by the Centers for Disease Control and Prevention, CDC. VRSA stands for Vancomycin-Resistant Enterococci. Normally a benign bacteria in your intestine and in female reproductive parts. Like MRSA, VRE bugs are resistant to the antibiotic vancomycin, but success can be found with other antibiotics. The CDC has it listed as serious. VRSA means Vancomycin-Resistant Staphylococcus aureus. It is causing some worries with healthcare professionals, as Staphylococcus aureus bacterium is also resistant to methicillin. This bug is on a close watch list but is listed on CDC threat level as concerning. It is usually caught at hospitals or long-term care institutions. Pneumonia. There are several strains of the bacteria that cause the most common form of bacterial pneumonia, pneumococcal pneumonia, THT, are becoming resistant to some antibiotics. This is especially true of penicillins. But it is also true of other types of antibiotics, including cephalosporins, macrolides, fluoroquinolones, and doxycycline. It takes longer to cure and requires more hospital assistance. Tubercluosis, TB, is caused by an organism that is resistant to the two most potent TB drugs. These drugs are used to treat all persons with TB disease 8. Still relatively rare, but growing in numbers like all superbug cases, is a strain that is not only resistant to the two more potent TB drugs, it's also resistant to fluoroquinolone antibiotic. NDM1 is shorthand for New Delhi Metallo-beta-lactamase-1. This is not a superbug per se, it is the creator of superbugs. It is a gene, DNA code, that turns relatively harmless bacteria into the most powerful superbug of superbugs. Any bacteria strain carrying the NDM1 gene is resistant to nearly all antibiotics, including carbapenem antibiotics, also known as the last resort 9. This gene, unlike others, passes easily from one strain of bacteria to another, and that is what worries medical professionals most. NDM1 is widespread in India and Pakistan, and it has reached Europe, the USA, Canada and Australia. In the beginning of this article I pointed out how quickly microbes were becoming resistant to antibiotics and that they're losing their effectiveness against bacteria quicker every time they appear on the market. The pharmaceutical industries spend upwards of $1 billion for every antibiotic they create. It did not take long for the industry to end research and development for antibiotics, since they were not making back the money they cost to make. For the last 10 years only 5 antibiotics are in development. 10. Unlike the hundreds of medications being developed for chronic diseases, medications for chronic diseases do not show resistance and they're taken for longer periods of time. Antibiotics are expensive to make, cheap to sell and are not commonly used for a long time. There is no money in antibiotics. Some sort of incentive needs to be in place to entice and lure the pharmaceutical companies back into making antibiotics. I cannot fathom any reason they would go back into the antibiotic making business, unless they were to make a profit or break even, whether through high costs or government subsidies. Health authorities around the world, including WHO, struggle to convince the public of the dangers antibiotic resistance presents and that it is a crisis and no longer is a what-if scenario, but a win scenario. There are a few simple things you can do to protect yourself. The biggest one is washing your hands frequently and keeping your environment clean. Take antibiotics only when it is appropriate to take and take it the way you are supposed to for the length you are told to take it. Educating yourself or at the very least staying up to date with news and developments. Be aware of your surroundings. Particularly in hospitals and old age homes, or other long-term care facilities. Bacteria have proven themselves to be resistant and determine life forms, they learn quickly and stay one step ahead of us it seems. We, humans, have yet to learn our lessons and continually keep making the same mistakes. Our attitude that antibiotics are a commodity and not a valuable tool in modern medicine, continues. But there is hope, we are finding new forms of antibiotics and discovering new ways to attack infectious disease. 11. Hopefully we will not have to watch the demise of modern medicine and the entrance of a new post-antibiotic era.
Thank you for watching this interesting and informative video. This channel offers motivational, inspirational, valuable and informative videos to soothe, cleanse and inspire your health, mind, body and spirit. You can find lot of interesting videos on wide range of topics here. Stay tuned and keep watching.